Hello and welcome to Virtualand. So today I want to talk about why physics and mathematics are really fun. But before you judge me, let me show you why. So today I want to simulate some particles, some physical particles, a sphere-like, and I will create gravitational forces between them. So each of them would have a mass, a gravitational field that would attract any other of these objects, of these particles. So this is an n-particle or n-body problem in physics. And it's not so easy to solve the equations of these n-body problems. I'm not going to go through all these 200 lines of code for you, but what I will do, I'm going to show you the number of particles, and we have a mass, and I will adjust this, and I want you to guess how the simulation will change. So in this case here, let's say we have 120 particles with masses ranging from 1 to 6, and this is the simulation of them. Now it is important to remember that I have also added damping force, or you can call it also friction. The speed of these particles will slow down as they go through the space and when they collide with each other. Now let's see how it will change if I change the number of particles to only 30 and increase the mass diversity. Can you tell me what changed here? As you can see, decreasing the number of the particles would also decrease the central force and their speed, even though there are relatively heavier objects present in the simulation. Now let's decrease the number to 8 and increase the mass. Interesting. Again, decreasing the number of particles would decrease the central force that exists between them, and it will result in a smoother transition, a smoother gathering. Now what I'm going to do, I want to calculate the center of mass, and I want to calculate the average distance of these particles from this center of mass. I will also plot this average distance versus time. That white bar in the middle is showing you the relative average distance of these particles from the center of mass, and you can see the center of mass written in the simulation. Now let's plot it, and you can see how this average distance decreases and have some oscillations, and as we go you can plot more and more and see that the average distance is decreasing continuously. Now, can you guess what's going to happen if I increase the mass in the simulation? And you can see, heavier object would result in a stronger force. So, a stronger central force also. And you will have this. Now let's even increase this further. Interesting. Did you see what happened? This strong force is resulting in more rapid and faster oscillations. Now let's decrease the mass and see what happens. And you can see the same number of particles. I decreased the mass, and here's what happened. Interesting, right? You can see, can you guess what's going to happen to the plot? No more rapid oscillations. The average distance is decreasing smoothly. No more rapid oscillations. Now let's increase the particles to 30. Again, small mass. Did you see what happened? They now have faster oscillations around the center of mass. So if I plot the average distance, faster oscillations. Let's increase the number of particles even further, 200. And wow, you can see. Can you guess what's going to happen? Even faster oscillations. And you can see something very amazing. This curve at the minimum of the oscillations. Do you see this shape? Can you guess why it's happening? If you study math or physics, can you derive the equation for this? And also keep in mind that these are 200 particles. Each of them is having 199 forces being applied on them. It's not easy calculations. And the fact that my laptop is handling this,
yeah, whatever.
now let's decrease the number of particles and increase the variety in mass. And here you see, can you tell me what happened? And can you guess how is the plot going to look like? Again, interesting. You also have that shape there. It's not as smooth as before, but again you have it. Let's increase the number of particles to 160. Even faster oscillations. You can see that the heavier objects are being gathered in the center, and the smaller ones, the lighter ones, are still rotating around them. Doesn't this remind you of something from astronomy or from subparticle physics? And here is the plot for it. You still have that curve at the minimum points. Now let's decrease the numbers to 20. And very smooth, slow oscillations. We have some kind of interstellar thing going on there. So let's plot this, and you can see how it goes. Still have that kind of curve, but very smooth and very wide oscillations. Okay, and you can play with these forces and friction, a number of particles and masses. I hope you enjoyed this video. In the future videos, I will show you more physical, mathematical, and even social simulations. So if you want to see them, please subscribe and remember to like this video. Take care and have fun.